Section 6.2, factoring trinomials. Alright, in this section, we're going to now look at factoring three-term polynomials, trinomials, because most of them follow the same kind of pattern. And again, this is something that hopefully you have already seen in Math 305, and should just be a bit of a review. So once again, because factoring and foiling or distributing are very closely related, they're kind of opposite operations, we're going to relate it to what we do when we multiply two binomials. Okay? So when we're multiplying two binomials, we typically use that FOIL process or the box method. Okay? So we would first multiply the x times the x, then the x times the minus 5, then the negative 3 times the x, or sorry, positive 3 times x, and then that 3 times the minus 5. So multiplying that out, we get x times x is x squared, x times minus 5 is minus 5x, 3 times x gives us a positive 3x, 3 times negative 5 gives us a negative 15. We can then combine our two middle terms to give us the expression, final answer expression. X squared negative 5x plus 3x gives us a minus 2x minus 15. Okay. So if we look at what our final answer was when we do a distributing problem using two binomials and relate it back to what we started with, we can see some patterns. If you notice here, the two numbers involved, the 3 and the negative 5, if we were to add 3 plus negative 5 or do 3 minus 5, it gives us this middle value, negative 2, the coefficient of the x term. If we were to multiply 3 times negative 5, negative 15, it gives us the constant value that's on the end of the trinomial, that is the result. So when we're trying to factor an expression that looks like this, when we're factoring a trinomial, we work backwards. We find two numbers that add to give us the middle term's coefficient, that also have to multiply to give us the constant value on the end. So we're just going to use that pattern to try to factor some of these things. So the basic form that we're looking at are when you have an x squared plus bx plus c trinomial. In other words, a coefficient of 1 on your x squared term. Because when you have a coefficient of 1, you don't see it, like right here. 1x squared is just written as x squared. So here's the rule we just talked about. We find the factors of our c value, the number on the end, so two numbers that multiply to give a c, that add to equal the b value, the number coefficient attached to x. So our first example here, we have x squared plus 2x minus 35. Okay. We want two numbers that multiply to equal negative 35, but there's a decent amount of numbers that can do that. They also have to add, in other words, sum, which is adding to equal, what do we say, 2. So we can start looking at, I'm going to make this 2 columns because we have to have 2 factors to multiply to get negative 35. So it's just thinking of some factors. We could start with, well, some combination. If you kind of think, the only real factors of 35 are going to be 1 and 35 and 5 and 7, but some sort of combination dealing with a negative. So if we were to try 5 and a negative 7, those would multiply to give you negative 35, but when we added them, 5 minus 7 or 5 plus negative 7, that'd give us a negative 2. So what that tells us is we just need to switch which one's positive and which one's negative. Okay, positive 7 and a negative 5, those will add to give us the positive 2 we need. Okay. So that pair didn't work, this pair does, so we grab these two numbers And this tells us the two numbers that are going to go inside the groupings, the parentheses with x. So this expression here equals x minus 5, x plus 7. Okay. Again, we were just looking for the two numbers that add to give us this and multiply to give us that. And the last thing, we can always check our answers. In this case, if we were to multiply these two binomials back out using the FOIL method or the box method, we should get back to the trinomial we started with. Well, the x times x will give us x squared. The x times 7 would give us 7x. But then combine that with a minus 5 times x, so 7x minus 5x would add to give us the 2x, and then negative 5 times 7 would give us the negative 35. So if we go back and FOIL it, it does check. Okay, so get another example. B squared minus 7b plus 10. So one more time, we're looking for numbers that add to give us the middle term's coefficient, and they have to multiply to give us the constant value on the end. So add to give us negative 7, multiply to give us that 10. You can make a table of values again, but I think most of us probably can multiply in our heads or use the calculator to find these. In this case, you do want to start by thinking more what multiplies to give you 10 rather than what adds to give you negative 7. So options 1 times 10 would give you 10, but those would add to give you 11, or not negative 7. So we obviously need a negative. We are going to need them both to be negative since they multiply to give us a positive, but they add to give us a negative. So the two numbers we would need here are going to be, if we took negative 5 and multiplied it by a negative 2, that would multiply to give us 10, a positive 10. And then if we added negative 5 plus negative 2, it would give us the negative 7. Okay? So negative 5 and negative 2 are the numbers that we need. Okay, don't grab the 10 and the 7. I'll see students do that a lot. Then minus 5 and the minus 2 are what we're looking for. So we can write our final answer as, open up two parentheses with b and b. We know it had to be b and b because we have a b squared right there. That's the only way we can get b squared. Then we just fill in these two other terms inside the parentheses. So a minus 5 and a minus 2. Once again, we could FOIL that out to check to make sure our answer is correct. I'll leave that up to you guys to do. Let's move on to the next one. M squared plus 6m plus 7. Okay, two numbers that add to give you 6, but then multiply to give you 7. Okay. So you got to start thinking of some factors that could do that. So start thinking of things that will multiply to give us 7. Since 7 is a prime number, there's really only one combination. Well, two combinations if you include the negatives. 1 times 7 will give you 7, but those numbers will add to give you 8. Also, negative 1 times negative 7 will give you positive 7 when you multiply, but those would add to give you a negative 8. Okay, so if you think about those two possibilities, 1 plus 7, that gives you 8. That's not going to work. 1 plus a negative 7, or sorry, negative 1 plus a negative 7, because multiplying these two numbers also would give us a positive 7, but adding them would give us a negative 8. That's not going to work. We need a positive 6 in the middle. But those are the only possible factors of 7. In a situation like this, well, we can't factor using any of the methods that we're going to learn in this class. So what we say is that we say the trinomial is prime. Okay? If it's not factorable, we call it prime. And so m squared plus 6m plus 7 is a prime situation. All right. Looking at the next example, same kind of setup, it just has two variables involved, but because it is still an x squared and then single variables, well, it looks actually completely different, but it is going to be a similar setup. So I'll kind of work through this one, show you how we can approach it pretty much the same way. Okay. So we have an x squared out front, which pretty much tells us when this breaks down and we have our final answer as a double parenthesis, we're going to have an x and an x multiplied to get that x squared. We're also going to have, in order to get this a squared on the end, we're going to have some sort of a here and an a here to get that a squared. So just keep that kind of thing in mind when you're going through these. So we still use the same idea with our coefficients. We need to find two numbers that add to give us 6 and multiply to give us negative 16. Alright? But then they have to combine in the middle. Yeah, so multiply to give us negative 16, add to give us a positive 6. So finding those two numbers, adding to get 6, multiplying, well, the combination would be something involving 8 and 2. One of them has to be negative since it multiplies to give us a negative. So we'd have to go a positive 8 and a negative 2. That's going to give us negative 16 when we multiply. 8 plus a negative 2 is going to give us a positive 6 when we add. So 8 and negative 2 are the values we want. So writing our final answer here, remember we said we're going to have an x and an x to get that x squared term. We know we're going to have an a here and here though, because that's the only way we're going to get this a squared on the end. So our numbers were 8 and negative 2, so we're going to have an x plus 8a and an x minus 2a, using those two numbers, 8 and negative 2. Problem like this, since it's a little bit tricky, a little different, definitely go back to FOIL it to check it. Okay? X times x gives you x squared. Let's write this down. I'll write it lightly since this is just a check. X times negative 2a gives you a minus 2ax. 8a times x gives you a positive 8ax. Those will combine to give us that positive 6ax there. And then 8a times a negative 2a gives us a negative 16. And a times a squared. So this does check to get us back to what we started with. But don't confuse this with the answer. The actual answer in factored form is this, turning it into the double parenthesis, a parenthesis factor times another parenthesis factor. Okay? This is just the check. Alright. And one more example, kind of combining everything we've learned so far about factoring. In 6.1, we talked about the first thing we want to do in every factoring problem is to check for something specific. And that is to check for a GCF, a greatest common factor. I didn't really mention that in the problems we just completed, although all of them, because the leading term was an x squared, or an m squared, or a b squared, or an x squared, we wouldn't be able to pull a number portion of a GCF out because there is no coefficient on any of those leading terms. However, you do still want to think about that every time you look to factor. So is there a GCF we could pull out? And remember from yesterday, or from whenever we did 6.1, that doesn't have to just be a number. So, looking at our three terms here, 16y to the third minus 32y squared minus 48y. We want to find the largest number that will go into 16, 32, and 48. And that we take for our GCF. But then we also want to consider the variable y in each term. So these are all even numbers, so 2 is definitely a common factor. 2 will go into all three of those. However, there's a bigger number. 4 will go into all of those. But so will 8, and so will 16. So you want to take the greatest common factor. 16 goes into 16, 32, and 48, so that makes it the greatest of the common factors. So 16 is going to be what we want there. Then we have 3 powers of y, 2 powers of y, 1 power of y. Remember, we can only take what they all at least have to have the amount of y's that we're going to take. So it really always ends up being the least amount. So 48y only has the single y, so we can only take out a single y for our GCF. Okay. So we write our expression, the original expression, we pull the 16y out front, and then we essentially divide it out of each term, or look back at what would we need to multiply by to get back to these three original terms. 16 times, well, we don't need a number out front to get back to 16. Technically, we would just need a 1, but y times y squared would get us to y cubed. 16 times a minus 2 would get us negative 32. Y times another y gives us y squared. 16 times a minus 3 will get us negative 48. And we already have a single y, and that's all we had in the original expression, so we don't want to put another y there. So factoring out the GCF, we get that. Okay. Well, from here, we need to approach this. Now we can approach this problem how we have been in this section, section 6.2. We kind of ignore the 16y GCF we pulled out front and just consider the parenthesis now. Looking inside the parenthesis, we have a trinomial of the form y squared plus bx plus c. Although even though they're minuses, we have a squared term, a single y term, and then a number by itself. Those are the same problems we've been doing all day now. So what we have to do is ignore that 16y for a second and just factor what's inside the parenthesis as an x squared plus bx plus c type of trinomial. Okay. So what are we looking for? Once again, ignore the 16y, but we want two numbers that add to give us the negative 2 and multiply to give us the minus 3.